Hello everyone. In this video we will do two examples finding arc length of curves given by a graph of some functions. Remember that if we have a curve y equal to f of x, then the arc length from a to b of this curve is going to be 1 plus the derivative of that function squared under the square root, then dx, yes? So here my function is e to the power x plus e to the power negative x over 2. As a result of that, well, the derivative is going to be 1 over 2 is just constant, yes? So this will be e to the power x minus e to the power negative x over 2. And then let's just write here, let's go from 0 to 1, root 1 plus e to the power x plus e to the power negative x over 2 squared dx. And okay, so let's see what is 1 plus e to the power x plus e to the power negative x squared. I just want to do simplification there. So this will give me 1 plus 4 in the denominator, e to the power x squared plus 2 times e to the power x, e to the power negative x, plus e to the power negative x squared. And this gives us 4 plus e to the power x squared. This must be negative. Yeah, that's why I need to use the derivative there, yes? So this will be minus, this will be, see, e to the power x times e to the power negative x is just 1. So I have negative 2 here, and this is squared over 4. I'll do one more step here. So this will be e to the power x squared plus 4 minus 2 is 2 plus e to the power negative x squared. Since we just came down with the idea that e to the power x times e to the power negative x is 1, so I will reverse that idea here. And you see that now I have one thing squared times twice of that thing times another thing plus another thing squared. So that is the same thing as e to the power x plus e to the power negative x squared over 4. So what I did show here is that will turn into e to the power x plus e to the power negative x squared over 4. Well, everything must be under the square root. And well, that simply comes out of a square root by dropping the power, so it will be e to the power x plus e to the power negative x over square root of 4 is 2, and now we can integrate that. That's just half of integral of e to the power x, which is e to the power x. Integral of e to the power negative x is negative e to the power negative x. Go from 0 to 1. And that is half of e to the power 1 minus e to the power negative 1 minus half of e to the power 0 minus e to the power negative 0. Well, this part is 1 minus 1, so this will disappear and vanishes that part. So this part will be half of e minus e to the power negative 1, which is e to the 1 over e. So the length of that curve, or the arc length of that curve, is half of e minus 1 over e. Let's do another example here. We have the function this time is the curve is given by x equal to f of y, well, g of y. Let's just go that way. And then in that case, you know that the integral is going to be given by a to b, or the length is going to be given by this integral a to b of root 1 plus the derivative of g with respect to y, square it, and then dy. So in our case, gy is ln of cosine y. As a result of that, g prime of y, the derivative with respect to y, is, so ln of anything, the derivative is the derivative of that part over that part itself. So here we get minus sine y over cosine y, which is negative tan y. Okay, so here then I have integral 0 to pi over 4 of root 1 plus negative tan y squared dy. Okay, so this is 0 to pi over 4 root 1 plus tan squared y dy. And tan squared, 1 plus tan squared is secant squared. And while in that interval secant is positive, so we will get just secant y dy, and we know that antiderivative of secant is ln of secant y plus tan y. Okay, then go from 0 to pi over 4. And we evaluate that, so ln of absolute value of secant pi over 4 plus tan pi over 4 minus ln of secant 0 plus tan 0. So this is ln of secant pi over 4 is root 2 plus 1 minus ln of secant 0 is 1 plus 0. And this is ln of root 2 plus 1 minus ln of 1 is just 0. So that is, I don't need to put that there. Okay, so that is the arc length, the graph of function given a curve, and then we are trying to find arc length of that